This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is example 17. We're going to solve this equation that has a fraction in it. Notice there are two terms on one side, so this is a little bit different than examples 1 through 16. Okay, so there are a couple ways to do these problems. One way is you just isolate the variable, since you've got the variable only on one side of the equation. So we could do that by adding the opposite here, or if you have minus 4, that means I'm going to add 4 to both sides. So then I've isolated this x, and I have 2/3 x equals 1 plus 4 is 5. And now at this point, you can multiply by the reciprocal to isolate the x completely and get just what 1x equals. And this is probably the most natural way for most people to solve this equation. We get x equals 15 halves. Of course, that's the same thing as 7.5 or 7.5. Usually when I'm solving equations, I leave things as reduced fractions. One less step that I have to do. Now, there are other ways you could do this. A common method, especially if there's more than one fraction, which we'll be getting to eventually, is to clear the denominator in step 1. So I have 2/3 x minus 4 equals 1. If you see a fraction, you don't want any fractions, we're just going to multiply both sides of the equation by the same number. And that would be the least common denominator. So in this case, the least common denominator is 3. So how am I going to show that? There's different ways you can show that. You could say, well, I'm going to put a parentheses around that and say 3 times that, and then I'm going to do a 3 on the other side. So let's do it that way. So I need to distribute this 3, right, to both of those. So that would give me 3 times the 2/3 x minus the 3 times 4, and then I have the 1 times 3, which is 3. Okay? The way I usually do it, just because I'm kind of lazy, is I'm going to take, well, I'll show you after I finish this. Let's go ahead and finish this for now. So this is going to eliminate fractions because when you have the 3 times the 2/3, that's going to cancel. That was the whole point of multiplying by the least common denominator. So I have 2x minus 12 equals 3. I get an equation without fractions, and then we just solve this the way we first learned how to solve equations by adding 12 to both sides. So we isolate the x term over here on the left, 2x equals 15, and then divide both sides by 2, the coefficient of x, to get x equals 15 halves. All right. Now I'm going to show you how I usually write this. Instead of putting a 3 on one side and a 3 on the other side, just show you a different way of doing this. I put a big bracket around the whole thing, and I say, all right, I'm going to distribute 3 to everything on both sides of the equation. And if you do that, it's going to look exactly the same, except that you might write 3 times 1 right here, right? So you have the 3 times 2/3, just like I have here. Actually, the 2/3 x minus the 3 times 4. Then you write the equal sign. Then you have to also remember to do 3 on the other side. So I usually put brackets around my whole equation. This is just the Julie, your math gal way of doing it. That's how I like to do it. Most books will not do that. So it's up to you how you want to show that. But in any case, I got 15 halves for the answer. So let's go ahead and check it. So we're going to check to see that 15 halves indeed checks. So we're going to replace x with 15 halves. So we have 2/3 times 15 halves minus 4. And let's see, you could write this as 30 over 6 and then get 5, or you could cancel. I'm going to do it that way. The 2's go, 3 into 15 goes 5, so I end up with 5, like I said 5 minus 4. 5 minus 4 is 1. On the right-hand side, I also have 1, so it checks. So therefore, x equals 15 halves is the correct answer. And if we want to write that using more formal notation in the solution set, we would write 15 halves in the braces. Okay, let's go back up to the beginning. Just to note again the two different ways we did it. One way is you didn't eliminate the fractions first. You just got the constants on one side by adding 4 to both sides, and then you multiply by the reciprocal. Okay, that works perfectly fine. But if you want, you could multiply by the least common denominator both sides of the equation first. And when you do that, you get an equation, 2x minus 12 equals 3. And then when we solve that, we got the variables on one side, constants on the other. So it depends on whether you want to eliminate the fractions first. And you'll find that if there's more than one fraction, it's almost always easier to multiply both sides of the equation by the least common denominator first. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.